Hello everyone and welcome to today's class. Today we are going to talk about spontaneity of chemical reaction and non-spontaneity of chemical reaction. Now, spontaneous chemical reactions upon spontaneous system, chemical system is those process in which the process proceeds on its own on the sets of some condition without any external help. Non-spontaneous processes are those processes which is required external help for its initiation and for its proceedings, for the reaction to proceed further. Let's try to explain this with some example. Now, if we talk about two sets of example, the very first one that is coming into my mind is that a hot body when is in vicinity with a cold body, comparatively colder body, heat starts to flow from hotter body to the colder body till the two bodies become much more two body becomes in equal amount of temperature. Now, this entire process happens spontaneously. We do not require to give any external help for this process to occur. This entire transfer of heat energy happens spontaneously from hotter body to the colder body. This is an example of a spontaneous reaction. Now, another example of spontaneous reaction that I am going to talk about is that when coal is left in an open environment, no such reaction occurs. But if you ignite the coal, the coal start to react with the carbon oxygen in the atmosphere and combustion reaction starts to happen. Now, after the ignition, no amount of external help the reaction requires. It can spontaneously the combustion reaction occurs. But at the initial state, an external ignition is required. An initiation process is required for this spontaneous reaction. So this is also spontaneous reaction. The process do not require any external help for its proceedings. This spontaneous process, the combustion of this coal, proceeds on its own without any external help, but it requires an initiation. An ignition is required. So these two are the sets of example of spontaneous reaction. A spontaneous reaction without external help, external initiation, and this is the example of spontaneous reaction with external initiation. Let's see the example of a non-spontaneous reaction. Now, we have known that if KClO3 is heated, oxygen gas is produced. Maybe MnO2 can be used also as a catalyst in this reaction. Now, in this entire reaction, KClO3, from disintegration of KClO3 to oxygen and other material also, heat is the external factor that is helping this reaction. If we stop the heating of this reaction, in this reaction, the reaction will stop. So for the proceeding of this reaction, heat and external factor is required. That is the difference between this second example of spontaneous reaction, where an external help is given but to initiate the reaction. After the initiation, the reaction is not required an external help. The combustion can proceed on its own spontaneously. But for the non-spontaneous reaction, heat, these external factors is required for the initiation of the reaction and also for the proceeding of the reaction. So non-spontaneous reaction, by definition, that a reaction which requires an external help. Spontaneous reaction, no, this is the definition. Non-spontaneous reaction, a spontaneous reaction by definition is the reaction or the process in which the process which can occur on its own on a given sets of condition without any external help. Now, which chemical reaction, which thermodynamic process is going to be spontaneous or non-spontaneous depends on few factors. Now the main factor is going to be that delta H value. It has been found that if delta H value is a negative, then the process sometimes becomes spontaneous. Now why I am talking about sometime? Let's take example of two example. Let's take an two example. In the first example, carbon, which is solid in nature, reacts with O2, gaseous in nature, produces CO2, which is gaseous in nature. Now, in this reaction, delta H has been found to be negative. It is a spontaneous reaction. Let's take another example. This is water, which is liquid in nature. After providing heat energy, it becomes vapor, gaseous in nature. Delta H in this process is positive. Energy has been consumed by the system to produce the vapor state of the water from the liquid state. So this is, in this process delta H is positive, but still this process is spontaneous. We can see that in the hot weather, if you pour some amount of water on the floor, after some time the water evaporate. The entirely spontaneously this process occurs by consuming the energy from its atmosphere. The liquid water evaporated to the vapor water. Now, these two are the two spontaneous process. In both of them, in one of them, delta H is a negative. In the next one, delta H is positive. So, what I'm trying to say is that delta H value cannot be the only factor which determine the spontaneity of a reaction. There is another factor. What is this another factor? Is the randomness of the system. That is how randomly, how freely the molecule can move around. I'm going to say it again. Randomness of a system means that how freely the molecules or the particles can move around within the system. The more the randomness, the more the spontaneity. More the randomness, more the spontaneity of the system. More spontaneous the system becomes. Let's take example, or let's look at the example. In the first one, delta H is negative, it is spontaneous. In the second one, delta H is positive but still spontaneous. In the second one, if you see, water was in the liquid state, and after the reaction the water has become in its gaseous state. We know that water molecule in gaseous state has more free motion compared to the liquid state, so the randomness has increased. Randomness has increased. Randomness has increases in this reaction. So we can say that randomness is another factor in which determine the spontaneity of a reaction. But there is another example. We know that when cloud gets uh, rain is we see rain falling. The process behind the rain falling is that water molecule in its gaseous state form clouds. When clouds gets heavier by combining with other water molecule, it fall as liquid water, and we call that as rain. So in this process, the raining process, water molecule from vapor state has transformed to liquid state, which happens spontaneously. Randomness of this process has decreased, but this process is still a spontaneous process. Condensation of uh, cloud water in vapor state is a spontaneous process. This raining is a spontaneous process in which randomness has decreased. Now, how this process occurs? Because in this process, energy has been released by the system. Now, that's why what I'm trying to say is that not only the delta H factor which will determine spontaneity of the system, or nor the randomness of this system will determine the spontaneity of the system, but spontaneity of the system depends on by the both factor, combining both the factor, that is decrease in delta H value and increase in the randomness value. These two, by combining together, will provide will provide a theory which can determine whether a process is going to be spontaneous or a process is going to be non-spontaneous. Let's see how. Let's see a process in which delta H is unchanged. No change in the delta H occurs, but randomness has increased. In that way, by combining these two factors, randomness and delta H, the process will become spontaneous. Let's say another process in which the delta H is unchanged but randomness has decreased. In this process will be non-spontaneous. Let's take the third way. The delta H value has decreased, but randomness of the process unchanged. That is, before the reaction, the amount of the free motion, the constant particle was there. After the process, the randomness of the constant particle, the free motion of the constant particle remains the same. No change has occurred, but the delta H value has decreased. So, by combining both of them, the process will be spontaneous. Let's take the fourth case, in which delta H value has increased, randomness of the process is unchanged. By combining that, we will find a non-spontaneous process. If delta H value decreases and randomness increases, both of them are changing now. Randomness has increased, which is favoring the spontaneous process, and delta H is decreased, which is also favoring the spontaneous process. So combining these two, it will be a highly spontaneous process. If delta H is decreased, increased, and randomness decreases, which is making the very non-spontaneous process non-spontaneous, and the delta H value also increasing, which is making the process more non-spontaneous. So by combining these two factors, the thermodynamic process that we were talking about will be highly non-spontaneous. If the delta H value for this process increases and the randomness also increases, of the process increases, which is making the process spontaneous, but delta H value increases, which is making the process non-spontaneous. So by combining these two value, right now we cannot actually determine, because one factor is making the process non-spontaneous, one factor is making the process spontaneous. We cannot actually determine right now whether the process will be spontaneous or non-spontaneous. So the process may be spontaneous, may not be. If the delta H value decreases and randomness of the value decreases also. In this last scenario, if a process in a thermodynamic process the delta H value decreases, the process will be non-spontaneous, but in the same process the randomness also decreases, which is making the process non-spontaneous. So in this case also we cannot determine whether the process will be spontaneous or non-spontaneous. It can be spontaneous, as may not be no spontaneous. So this is the factor through which we can determine whether a process will be spontaneous or non-spontaneous.